Volcano, yep. Yep, so number one there, volcano. Number two, this is the middle layer of the Earth. What's the middle layer? The middle layer, so the Earth, right, you got the core in the middle and the crust on the outside. So what's that middle layer called? Starts with an M. Yeah, mantle, the mantle. Mantle is the middle layer of the Earth. So it's not the innermost layer, it's not the outermost layer, it's in the middle. And then number three, two plates pushed together to form what kind of a boundary? Well, transform is when they're sliding side by side. Convergent, that's right. Okay, so number three, two plates pushed together to form a convergent boundary. And number four, this is a break or crack in the Earth's surface caused by movement. Yeah, this one's with an F. Yeah, fault. A fault is a break or crack in the Earth's surface caused by movement. And here we go, number five, two plates slide next to each other at what kind of boundary? Yeah, transform. Transform boundary. And number six. So number 6 and 7 look pretty similar in their wording, and that's why for number 7 I had underlined those two words, large block. Okay, so number 6 is a bit more general than that. So the crust and the rigid upper part of the mantle. Hello, good morning. You found us. Go ahead and take a seat. We're just started. All the answers that you missed are on the board. We're starting with the worksheet here from Unit 2. If you don't have it, I've got extra copies here. These are both the worksheets we're going to go over. So we just went through answers 1 through 5, guys. So if you have your worksheets that you already have worked on, you can check your answers, otherwise you can fill them in. Okay, do you have both of the worksheets? I've got extra copies. So you got this one.
The second,
That's
the
fine.
second one I tried to.
That's fine. Here you go. Who knows the answer for number 6 then? The crust and the rigid upper part of the mantle make up what part of the Earth? Not yet. Close. And so there's crust and the rigid upper, so it's not the asthenosphere, it's what? The lithosphere. Yeah, so the crust and the rigid upper part of the mantle make up the lithosphere. Number 7, the wording is similar, okay? And I had just said before that that's why I had underlined these two words, large block. Okay, so this is a large block of the crust and the rigid outermost part of the mantle. No. So what are these things that move around and shift?
No.
A large block of the crust and the rigid outermost part of the mantle. Right, you saw that, you can actually see them all divided up on this map in the back. What are these things?
Tectonic.
Tectonic plates. Number 7 is tectonic plate. Number 8, the soft layer of the mantle on which the tectonic plates move is called the starts with A. The A word. Asthenosphere. The asthenosphere. Remember, it's the convection that's happening in the asthenosphere that causes those tectonic plates to constantly move around and shift.
I think we're going back to review it from the beginning because I was trying to have kind of like the understanding of the terms.
There's all these different terms, lithosphere, asthenosphere.
I want to try to read to understand the
Right.
similarities that close, so it's hard to distinguish.
It's true. It is. So some of the words are very close, like, even lithosphere and tectonic plate, those definitions are very similar. But a tectonic plate is just a large block of the lithosphere, really. That's moving on the asthenosphere. Okay. What about number 9? So at this type of boundary, seafloor spreading occurs to form new oceanic crust. What kind of plate is moving apart?
The
That
divergence.
divergent boundary. Okay, and then the last one there, number 10. This material rises to the surface of the earth and provides scientists with the opportunity to study the earth's interior.
Magma.
Magma, right? The last one. Was that of a volcano?
The magma is a hard material,
Oh, yeah.
red one,
Yes.
circulates.
Certainly, certainly. Very, very hot material. But when it comes up to the surface and it comes on out of the middle of the earth and hits the air, it starts to cool. Or if it comes underneath the ocean.
Forms the mountain range.
That's right. It can form mountains on land, or else if it seeps out of the bottom of the ocean from a divergent boundary, then it makes new oceanic crust. It makes new crust, right? It makes mid-ocean ridges at the bottom of the ocean. It makes those underwater mountain ranges. So it can seep up in many different places. It can erupt from a volcano on the surface, the magma, and then it cools and hardens into a black igneous rock. Or else it can seep up through the bottom of the ocean floor and also harden into igneous rock, making up mid-ocean ridges. Okay.
Can we do that? Because we missed the fourth one. So.
These ones? Okay.
Just an explanation. Like,
That's fine. So number 1, it said molten rock or magma can rise up through a volcano, which is a large opening in the earth, right? Allows the magma to travel upward. So that's why number 1 was volcano. Number 2 is the middle layer of the earth and that's the mantle, because if this is the earth, this thin outermost layer represents what? What's the thin outermost layer of the earth called? It starts with a C.
crust.
A crust.
But the thin one is the continental crust.
Well, the oceanic crust is the one that's thin and young, and the continental crust
Which one
is
is
the one
the
that's
first?
thick and old.
It's the oceanic, then the continental. Right?
Well, it depends on where you are. It depends on where the land masses are. We're going to differentiate the different kinds of crusts on the other worksheet. Okay? So, but that's the crust, and then what's this thing in the middle here? What do you call that? The core. And so this very large middle layer of the earth, that's the mantle. That's the mantle. Okay. Earth gets split into 3 general areas. The crust, it's rigid and brittle. The core, okay, the very center of the core is a metallic mass, solid metal. And then the outer core is molten. And then the mantle is so large it actually has 2 different types of characteristics. from the rocks that are being heated around the core. The core generates a ton of heat. It's the other source of energy on Earth. Good morning, go ahead and take a seat. If you need the two worksheets that we're going over, I have extra copies for you there. But there's a lot of heat. The heat that's emanating from the core is actually left over from the Big Bang. And so it's all this really intense heat, and so it melts the rocks that are surrounding it, and that's what makes up the asthenosphere. That melted rock, and it moves as it gets closer to the crust, the lithosphere, it starts to cool down. All right? Some of that material seeps upward and out under the ocean or onto the land through volcanoes or mid-ocean ridges. Okay? But otherwise, it kind of constantly circulates. And that's what causes the chunks of the lithosphere, the tectonic plates, to move around. Okay? So the number 3, 2 plates pushed together form a convergent boundary. That means the plates are coming together. That's when you'll have mountain building, you'll have earthquakes. Okay? A fault was a break in the or crack in the earth's surface caused by movement.
What's the fault?
A fault is an actual fissure. So like out in California, there's the San Andreas fault. Have you ever heard about that, the San Andreas fault? And it's actually a break, a fissure in the earth that you can see. So there's like this big mountain range, but then there's the sides of the fault, and there's like a big line down the middle. So this is the mountain, and then you got a big crack right down that mountain. And that's because of the movement of the tectonic plates. There's a real picture in your PowerPoint lecture. It's an opening. It's an opening. And so some boundaries ran together, right? That's convergent. Some of these faults spread apart. That's divergent. But the San Andreas fault is a transform boundary. And what do transform boundaries do? They slide side by side. Side by side.
They spread out.
They don't spread out. The transform boundary, like the San Andreas fault, moves like this. Okay? But if it's going like this, it's going to break and cause all the rocks that were in the middle to break down into like basically dust. Okay? This one doesn't go forward or away, it slides side by side. Okay? So that's, and this is being recorded, so you can watch this over and over again. Okay? Let's go ahead and move on, though, because I do want to make sure we have time to cover everything. So the back side of this worksheet, we've got these 3 questions where you're asked to analyze the map. So for number 1, looking at this map, what type of a boundary is found between the Eurasian plate and the North American plate? So here's the Eurasian plate here, and here's the North American plate, and you can see that that movement between those plates is at a rate of 2.3 centimeters a year. So what kind of a boundary is that? You see that? So the plates are moving away from each other. So that's a divergent boundary. And what may form, and what has formed actually, at that divergent boundary in the middle of the Atlantic Ocean? What's there? So if the seafloor is spreading And then for number 2, the Andes Mountains are located along the western coast of South America. All right, so take a look at what's going on there in South America. How were these mountains formed? Which way are the arrows going? So look at the Nazca Plate and the South America Plate. What's going on there? At a rate of 10.1 and 11.1 centimeters a year. Are they moving together? Are they moving apart? Or are they moving side by side? They're moving together, right? So what do you call that? What kind of boundary? Convergent. Okay? So what you've got going on between on the western coast of South America is convergence. Convergence or convergent boundary. And that's what builds the Andes Mountains. Okay? The mountains were formed by convergence. The Nazca Plate is colliding with the South America Plate. And then at number 3, you gotta look at the rates of movement, the numbers on the map to figure out the answer to this question. Where does a divergent boundary appear to be forming at the fastest rate? Where do you see that? Where's your biggest rate of movement? You see those numbers? 7. Yeah. 17.2, right? And 16.8, right? Those are the biggest numbers. So what 2 plates are moving apart that fast? One of them is definitely, which one? It's not the Cocos Plate. See, this map is a little bit weird because you'll see that the Cocos Plate label is actually, there's a straight line that points to that small plate right underneath Central America and Mexico. Okay? So, it's not the Cocos Plate. What's this big plate? Well, so yeah, the Nazca Plate's one of them, and what's the other plate? What's that really big plate there out in the middle of the Pacific Ocean? It's the Pacific Plate, right? Pacific Plate, okay? See that Juan de Fuca plate is pointing to that small plate, you know, basically like next to like Washington or Oregon, okay? The Cocos Plate is pointing to that little tiny plate underneath Mexico. But the Pacific Plate is that gigantic plate.
So we determine that by the numbers?
Yeah, exactly. So the biggest rate of movement is 17.2 and 16.8, right?
Is it like Richter?
No, this is centimeters. This is centimeters a year. So those plates are moving apart by 17.2 centimeters a year. That adds up. And that's in fact why the Nazca Plate rams into the South American Plate so often, causing a lot of earthquake activity there and constantly building the Andes Mountains. So the Nazca and Pacific plates are definitely moving apart at the highest rate, as the highest rate of divergence. Okay, are we good on that worksheet?
So when we take a look to the map, I mean the wall around, so when we see continents that spread around.
You're not going to have a map like this on the test. You know, sometimes it can be unclear. So it's just for the purposes of visualizing something, but you won't have to worry about like an unclear map with lines going here and there like on the test. Okay, but it just does help to visualize where you have divergence, where you have convergence, and where you have the greatest types of movement. Yeah, all these numbers are indicating centimeters of movement per year. Okay, I gotta make space, guys. So you guys all have these answers in blue now, at least for the front side of the worksheet. You can get rid of this. You got this down. Okay. All right, so now we're going to move to the other worksheet, the big exam review handout. I emailed you guys a few days ago. Did anybody have any time to work on the answers or no? college, the field of environmental science, remember that? Do you need chemists and biologists and politicians and economists? Do you need all those different people to address environmental issues? Remember that? Yeah. So we call it an interdisciplinary study. So environmental science is defined as the interdisciplinary, that's key, study of the connections between nature, and that could be living and non-living components. As well as what? What else do we look at and address in environmental science? So we're studying the connections between nature, the living and non-living components, and we try to come up with solutions, right? Solutions to environmental problems. So as well as solutions to environmental problems. And there are really a number of ways that you can define environmental science, but something along the lines of this would definitely fit the bill. Okay. The interdisciplinary study of the connections between nature, which includes the living and non-living components, as well as solutions to environmental problems. Number 2, that's that question that I actually had told you guys in advance that you could actually expect as what on your test? You guys remember? As one of the extra credit questions. Remember on your exams you're going to have like 2 or 3 short answer extra credit questions. And I already kind of gave you guys a gift telling you that number 2 there, what are the 3 foundations of sustainable development, is going to be one of them. All right? So what are the 3 foundations of sustainable development? Do you remember? They're types of decisions. What kind of decisions do you have to make for sustainable development? How about environmentally sound decisions that can't harm the environment? We have to be able to pay for it, right? The benefits have to outweigh the costs. And so where are we going here? Okay, economically viable decisions. And the last one, last but not least, is that the benefits and costs are those who live in poverty more subjected to poor environmental quality and more environmental harm?
Yeah.
What? Yeah, right.
Yeah.
Okay, and that violates environmental justice, certainly, okay? So unfortunately, the fact is that those who live in poverty tend to be exposed to more environmental harm and poor environmental quality. Remember in the lecture, there was that picture of that low-income school, and their playground in the school itself really was right next to a factory, which is spilling out air pollution, okay? Here in our local area, the poorer neighborhoods tend to be located near landfills. Okay? So that is true. Those who live in poverty do tend to be exposed to more environmental harm and poor environmental quality. And that does violate concepts of environmental justice. And then there's even the more recent example of the people in Flint, Michigan, who, about half of the people, I think it's even 60%, live below the poverty line. And then their state government actually diverted a certain type of water source from a river that wasn't tested properly or treated properly, and then it caused the people to be exposed to lead poisoning. Okay, so this happens all the time. It's currently a topic of arguments. It's happened. It's a topic in the news right now. What's going on there in Flint, Michigan? Definitely exemplifies this issue. Okay. So in number 4, we talked about these two historic worldviews of the biocentric preservationist and the utilitarian conservationist. So what's the difference between those two worldviews, and what figureheads really embodied those worldviews, represented them? Okay. So first of all, a utilitarian conservationist. How do they value resources? Based on what? Remember? Utilitarian conservationist values resources based on their usefulness to who? Who's it all about? If you're a utilitarian conservationist, what do you care about? Are the resources important to who? To butterflies? To wolves? To humans? Who is it all about? To humans, right? The utilitarian conservationist only wants to conserve a resource that can be utilized by humans. So that could be trees in the forest that can be used for lumber or paper materials. It could be minerals in the earth that we are going to use, economically valuable minerals, things like iron and silver, gold, okay, copper.
It's kind of like subjective.
Mm-hmm.
They are subjective, or
Subjectives? What do you mean?
you mean like they tend to work for something that has value to use to.
Yeah, they only want to conserve a piece of land if that land has resources within it that people can use. Okay? So it could be for lumber material, it could be for minerals, it could be even for the pleasure of hunting and hiking and fishing. Okay? Having natural spaces like that for people to use and benefit from. Utilitarian conservationist. And do you remember what person was actually a president
Yeah.
of the U.S.? Wasn't Muir. Muir wasn't a president.
No.
He's the other one. Who's the one that was the president who eventually, who had this worldview and even founded the national park system to make sure that there were pieces of land that could be used by humans? Remember, who is it?
It's related to the national park in Hitchhiking. Remember that?
It's the guy who founded the national park system, Teddy Roosevelt. So there were two U.S. presidents that of the name of Roosevelt, right? There was Teddy Roosevelt, and then there was Franklin Roosevelt. Franklin Roosevelt was the president during the Depression and World War II. Okay, Teddy Roosevelt was before him. They are actually cousins. But it was Teddy Roosevelt who was the utilitarian conservationist. How about a biocentric preservationist? What is a biocentric preservationist? What's their worldview? How do they value resources? Biocentric preservationist values resources. Why? Values all resources. Because all life deserves equal respect and has intrinsic value. Biocentric preservationist considers that whether it's grass or caterpillars or humans or apes, everything is equal. Everything deserves equal protection. And who was the person who embodied this? This one is
You?
Muir. Yeah, John Muir. The founder of the Sierra Club, major environmentalist group. You guys have any questions on that? For number 5 and 6, we just got a couple of short little fill in the blank questions. So, what about number 5? A good hypothesis. A good hypothesis makes what about experimental outcomes? Starts with a P. And we're on number 5 in the study guide. Number 5 starts with a P, the answer. Good hypothesis makes a. So what is a hypothesis? How do you define a hypothesis, first of all? 2 words. An educated guess. So what's a nicer way of saying guess that starts with a P? A prediction. Okay? So a good hypothesis makes a prediction about experimental outcomes. An educated prediction or educated guess will be synonymous. Number 6, how is the human population growing currently and ever since the Industrial Revolution? Exponentially. The human population is growing exponentially. And do you remember what does the growth curve look like? What letter? There's a letter that represents it. So exponential growth looks like this. So if this is your graph, and your growth curve looks like this. What letter of the alphabet does that look like, kind of? A J or an S? And you could say, so one of the things could be controlling runoff, right? Controlling runoff, or using less fertilizers, right? Because excess fertilizers running off into a lake or a pond can cause eutrophication. Remember that? Okay? So you can
What do you say
runoff is when it rains and that rain hits the land. Anything that's on that land, whether it be pesticides or fertilizer or animal waste, that all ends up getting washed into a river, a lake, or a pond. And that's pollution in the water. That's water pollution. Okay, runoff is carried by rainfall, and then it washes into an aquatic system. It can go into the ocean or a freshwater system like a river, lake, or pond. Okay. All right, how about another environmental problem for somebody else who hasn't given me one? Give me an environmental problem. Come on, guys. Anything. What are some more examples of environmental problems? No?
Any virus, diseases?
So you're saying like biological pollution sort of thing, right? So if you have biological, it's kind of another type of water pollution, but biological pathogens in the water, and the possible solution to that is boiling water, right? That's something. It's sort of a subcategory of water pollution. Just something else that's sort of a little bit different, though, would be habitat loss, right? Habitat loss, that's an environmental problem. So what's a possible solution to habitat loss? If trees are being lost in one area, what can we do to fix that? What's the solution to losing trees? We can plant more trees, right? Plant more trees.
Probably because of the drought.
A drought, so yeah, environmental problem, drought. And so possible solution to be capturing rainwater, using rainwater retention barrels.
And this is really the way they treat the soil. It's not the right one to plant.
Yeah, and sometimes the soils become acidified and they're not capable of supporting agriculture. We're going to talk more about that in Unit 6. We're going to talk about how soil gets degraded and it's not capable of agriculture.
I remember that they use this white chemical pot to
make the soil more fertile?
yes.
Okay. Okay, but you can see that your answers could be very different, as long as you're able to identify a problem and a solution, that's what's important. We're going to be talking more about that throughout the whole term.
Would overpopulation is one.
Of course, that's a good one. Yeah, overpopulation is another environmental problem. There's not really an easy solution to that, but what is a possible solution to overpopulation? Birth control.
Like China?
Birth control. It doesn't have to be like that kind of policy, but it could just be,
I wonder, they say that.
condoms
I
and
think
birth control pills and
it's the
stuff.
number one in the world, China, and they started with birth control, but they ended up with 1 billion probably. 1 billion. It's almost 2 billion.
Question is tough. Does it work 100%?
What?
Birth control.
Well, it depends on what kind you're talking about. The things like, the pills and the injections, it's like 99% effective.
Because I don't know if something but this it doesn't work.
It depends, it needs to be used properly and regularly. It depends, there's so many different types of birth control. And of course, depending on, social and religious values of different cultures, things like that may be prohibited. So it really depends on what area of the world we're talking you actually see, that there's going to be a decline in growth. Do you guys remember what that's for? What's the whole purpose of an age structure diagram? To predict what? To predict future population growth. That way you know what areas of the world you can expect to have the largest increases in population. The whole purpose of an age structure diagram is to predict future population growth. And that way you can always prepare for a possible humanitarian crisis in the future, right? If you can expect a poor area of the world to have such an explosive growth in population, then it might be time to start preparing to store away some water, store away some food for those people. How about number 9? There was a couple of different people we talked about in that history area of the lecture in Unit 1. Which 20th century naturalist is regarded as the trigger for the modern environmental movement that we're still living in today? Do you remember? It was actually a woman. Remember what her name was? She wrote a book about the effect of pesticides on wildlife. Remember what her name was? Rachel Carson. Remember that? So Rachel Carson was the 20th century naturalist whose book, Silent Spring, was published in 1962. And it led to the formation of NEPA, the National Environmental Policy Act, which was an act created by the federal government, which also created the Environmental Protection Agency. So it was the first time the federal government basically saw environmental issues as a priority. Okay? And it all started based on her work, Silent Spring. Number 10, we just went over this when we were talking about the answers to that first worksheet, right? So hopefully you guys will all get this right. The San Andreas Fault is an example of what kind of a boundary? Convergent, divergent, or transform? Transform. Transform boundary. Perfect. How about number 11? This is, remember you wanted to talk about the differences between the two different kinds of crust, so here we go. So the oceanic crust compared to the continental crust. Let's list out some differences. So first of all, and most simply, where is oceanic crust? Where is it located? Where's the oceanic crust located, guys? Is it the land or is it under the ocean? Oceanic crust. It's the ocean floor, right? So it's below the ocean. This is the land below the oceans.
Question.
Yeah.
When we say crust, we're talking about the ocean. What about when there is water? Just the land, what do we call that? The upper part of
What are you saying?
talking about the crust and the ocean part.
Well, the crust underneath the ocean water is oceanic crust. So it is the crust. It's just covered by ocean water. But it's still crust.
So the same thing about when the ocean is the land, so both we call them crust.
Yeah. The ocean floor is oceanic crust. And then the land, right, the land masses
Could we call it
is the continental crust. Right, that's simply a description of where it's found. Now what about how are they characterized? Is the oceanic crust thick or is it thin? Thin. Okay. All right, what about the continental crust? Is it also thin?
Thick.
No, it's thick.
Thick and cold.
And what about the age? The age. Which one's older?
The continent.
The continental crust is old. rocks are shifting and breaking. Okay, so we call that energy seismic waves. Energy is released in seismic waves. Where is that release of energy most strongly felt? This place, right? The epicenter. Okay. So the epicenter is where? Where is the epicenter?
It's below
Is it below the focus or is it above the focus? It's above the focus. Epicenter is directly above the focus. So it's the surface of the land that's directly above the focus. The focus is in the crust. Okay? And the epicenter is where the release of energy in seismic waves is most strongly felt. Okay, does that make sense? Okay, so now we are getting to, we're going to do some of the atmospheric stuff, and then we're going to get into some of those water questions. So number 16, what are the two most common gases in the atmosphere? What is it? Nitrogen. And how much of the atmosphere does nitrogen represent? 78%. Okay. And what's number 2? Oxygen. And what percentage is that? What? What is it? 20-something percent, right? What is it?
28.
Not 28. 28 plus 78 would be over 100%.
Sure.
So what do we need? 21%, right? 99% of the atmosphere is just these two gases. Okay, so the two most common gases in the atmosphere, nitrogen and oxygen. Don't forget that. All right, so we got a fun little blank question here, 2 blanks to fill in. So this type of gas is present where in the atmosphere? It helps to protect against UV radiation. Or what is that layer in the atmosphere that protects us from UV radiation? Starts with an O. Come on, guys.
Ozone.
The ozone layer. Ozone. And where is ozone present? Right? We talked about a few different layers of the atmosphere. We talked about the troposphere, the stratosphere, the mesosphere, and the thermosphere. Where is it found? The stratosphere. Ozone is present in the stratosphere and helps to protect us against UV radiation. Okay. So now we're going to just kind of differentiate the Coriolis effect and the greenhouse effect. And the only reason I have them both in this question is because they're both two effects that you guys have learned about. But do they really have anything in common at all? Do you guys remember? Do the Coriolis effect and the greenhouse effect have anything in common? No, they don't. Okay? But I just wanted to make sure you guys don't get these two different effects confused. So the Coriolis effect versus the greenhouse effect. So first of all, let's talk about what causes each of them. Okay? What causes the Coriolis effect? Remember? Coriolis effect is caused by both hemispheres. So we've got the northern hemisphere and we've got the southern hemisphere. Do you remember which way the wind and water bend? So let's say this is the Earth, and let's just say that this is the equator. Okay? So this is the northern hemisphere, and this is the southern hemisphere. Because of the Coriolis effect caused by the Earth's rotation, wind and water in the northern hemisphere bends in which direction? Clockwise or counterclockwise? Remember? Come on, guys. Clockwise. Yeah, don't be shy. Clockwise. And the southern hemisphere, thus it bends counterclockwise. Okay? That's all caused by the Earth's rotation. The greenhouse effect is something that keeps the planet warm and habitable. Okay, so the greenhouse effect keeps the planet warm and habitable, and it's caused by what? Well, methane is one of the gases that's important in the greenhouse effect, okay? But what's the bottom line? We'll talk about that, but what's the bottom line? So some heat gets trapped, and some heat from the sun reflects back out into space, right? We don't want all that heat from the sun, it would get too hot, all right? So this is caused by the absorption of some heat from the sun by what kind of gases? What's the general catch-all term for these gases that absorb and trap heat? They're called what kind of gases? Greenhouse gases. Okay, by greenhouse gases. And some examples of greenhouse gases are methane and carbon dioxide and water vapor. Okay, those are all important greenhouse gases. So it's caused by the absorption of some heat from the sun by greenhouse gases and the reflection of some heat back out to space. Okay. What types of surfaces on the Earth are good at reflecting some excess heat back out into space? What kind of surfaces on Earth? Dark surfaces or very, very light surfaces? Light surfaces, right? Like ice and snow. Ice and snow are the best at reflecting that heat back out into space.
I was thinking, let's say causes wind and water to what?
To bend. All right, so the greenhouse effect is something that keeps the planet warm and habitable because some of the heat gets trapped within the Earth's atmosphere by greenhouse gases, and some of the heat reflects back out into space, especially when it hits snow and ice. You guys okay with that one? All right, we're almost done here. So number 19, how does temperature drive the circulation of the Earth's oceans? Number 19. Go ahead. So it's all about convection, just like when we talked about how the material within the Earth moves by convection. And so you have a process of heating and cooling, right? And so in the ocean, when you have, so this is the equator, okay? And the picture that's in your PowerPoint lecture is obviously a lot better than that crude drawing that I just did. But it's all about vertical mixing, okay? Heating and cooling is driving the movement of ocean currents. The same thing that happens within the Earth, causing those tectonic plates to move around on top of the atmosphere. And for the answer for letter B here, what other type of circulation is also driven by temperature that we talked about? So oceanic circulation is driven by temperature that we talked about here. The circulation of the molten material within the Earth is driven by temperature changes. What other non-living factors we also talk about that also moves and circulates due to temperature, right? Think about prevailing winds, like polar easterlies and westerlies and trade winds. What causes that movement, guys? What kind of circulation is that? So it's caused by temperature. What am I talking about? What are prevailing winds and trade winds and westerlies are all types of what kind of circulation? Start with an A. Atmospheric, right? Atmospheric circulation is also driven by temperature. Right? As the air is nearer the surface, it warms up. And as that air warms, it rises. And as it rises in the atmosphere, it cools. Okay? And then the cool air sinks back down to the surface where it warms back up. And then the warm air rises and it cools down, and that process just happens over and over and over again. Atmospheric circulation. Okay, number 20. Number 20, during El Nino years, waters in the Pacific are what? Cooler or warmer than normal? Do you remember? During El Nino,
It's warm.
which is going on right now, by the way, in the Pacific Ocean, the waters are warmer than normal. While during La Nina, waters are cooler than normal. Okay? Which of these events has a negative impact on fisheries? Is it El Nino or La Nina? El Nino. El Nino devastates the productivity of South American fisheries. Okay, that's good. Yeah, we just talked about that last, right? Pretty much, we talked about it yesterday. Okay, and then something else we talked about yesterday in class was the differences between the two different kinds of aquifers that we have here in Florida. So we have the Biscayne aquifer and the Floridan aquifer. Okay, so one of the things that you guys learned about was that some aquifers are confined and some of them are unconfined, right? Which one of these is the confined aquifer? Floridan, right? Located in between impermeable layers of earth. And so Biscayne is therefore what? Unconfined. Partly because of this, and also because of historic geology, which one of these aquifers is a bit salty or brackish? Which one is the brackish or salty one? It's not completely fresh. Not Biscayne. Floridan. Brackish to salty water, whereas the Biscayne aquifer water is completely fresh. Which one of these aquifers provides water to us here in South Florida? Biscayne. Okay. Water for South Florida, and the Floridan aquifer provides water for who?
All Florida.
Everyone Central Florida and North Florida. Good. You guys know that, that's fresh stuff, right? Okay.
Especially when you mentioned that we still have implementation with Georgia.
Great. All right, so we've got 3 more questions left. All right, so the next one is to either diagram or describe 3 processes of the hydrologic cycle. Okay, so if you see a question like that for extra credit, as opposed to a regular multiple choice question, you can always diagram it. That might even be easier for you. I don't know. But let's just go ahead and I'll do a little diagram. So let's say that this is the ocean. Okay, and this is the land. That's a really ugly tree, but that's fine. All right, so the first step in the hydrologic cycle, when the sun's energy heats the ocean water or a lake or a river, what happens to this water? What does it do? What's the first step? Evaporation. Okay? So the water is transformed from liquid to gas, and it rises in the atmosphere. That's evaporation. Then this water that has evaporated rises in the atmosphere and cools and turns back into liquid droplets that are held in clouds. So what's that step called? The first step is evaporation. The second step here is, starts with a C,
Condensation.
condensation. And then eventually there's too much droplets in this cloud, and so this cloud dumps what?
Precipitation.
Yeah, precipitation. So precipitation then happens. Okay. That's the 3 primary steps of the hydrologic cycle. Evaporation, liquid water is transformed to gas. Condensation, the gaseous water, the water vapor turns back into droplets, condensation, and in precipitation, the liquid water returns back to the surface. Okay? There was 2 other parts that we can always talk about, is that there's a special term that describes how actually water evaporates from plants and vegetation. Do you remember what that's called? It's liquid water being lost from plants and also rising in the atmosphere. That's called transpiration. Remember that one? Okay. The same thing. Liquid water that's in plants is turning into gas. And either the water that evaporates or transpires then condenses and then can fall back to the earth. And then some of this water that falls back to the earth actually will trickle through the layers of soil, right? And then eventually end up in aquifers, right? Okay? And so we can call that the process of percolation. general catch-all term is what? Your favorite word, it starts with an R. Right? Right, it rains on the farms, carrying the pesticides and the fertilizers. Runoff. Runoff. Runoff is the catch-all term for non-point sources of water pollution. It rains and it falls on the roads and the parking lot, okay, carrying all that nasty oil that drips from our cars into a body of water, okay? And the last question is a two-parter. So number 24, why do some experts consider water the most critical natural resource for the 21st century?
First reason is, 2.5%
Yeah.
fresh water.
Okay, perfect. So only two, so basically all living things need water to survive, and only 2.4% of all the water on Earth is fresh. Okay? All living things need fresh water. And only 2.4